All right, bases other than E. And we're going to do derivatives and integration with them today. So let's just start right off with some of the rules. If function of x is equal to a to the x power, then the derivative is equal to ln a times a to the x power. If function of x is equal to a to the u, just meaning something a little more composite than just a simple x, then f prime of x is equal to the natural log of a times a to the u times u prime, which is just a result of the chain rule. So one quick example of that would be if g of x is 3 to the 2x plus 4 power, the derivative, now you take the natural log of the base, which is ln 3, times, you just repeat what's written, 3 to the 2x plus 4 power, and then this times 2 comes from the derivative of the 2x plus 4. You could rewrite a little bit and rearrange. Most people will put the exponent out front of the numbers out front of the natural log, but all the same, it's all multiplication, which is commutative. Another example would look like this. If y is equal to log base a of x, then dy dx is equal to 1 over ln a of 1 over x. 1 over ln a times 1 over x could be written 1 over ln a x. If that x is something a little more complicated than a simple x, you just use chain rule again. Dy dx is equal to 1 over ln a times u times the derivative of u prime. So an example of that would look something like this. If y is equal to log base 4 of 6x squared, then that's 1 over ln 4 of 6x squared times 12x. 12x coming from, of course, the derivative of 6x squared. So we clean that up a little bit. We cancel 1x up top with 1 on the bottom. We cancel the 6 with the 12 on the top, and we get 2 over x ln 4. Moving on to some integration, if I have the integral of a to the x dx, that's equal to 1 over ln a to the x plus some constant c, which pretty much makes sense because if I took the derivative, I've got ln a times a to the x. So if I take the integral, it makes sense that I got 1 over ln a times a to the x because those two things should cancel each other out. And again, if you have a little more complex part of the x here, there's no really set rule, but you're going to have to do a u sub of some sort. So looking at one example of that, if I have 2 to the sine x power times cosine x dx, I let u equal sine x. I understand that du is cosine x dx, so all this part here is just du. So basically I've got the integral of 2 to the u power du. I use the 1 over ln2 bit here happening in the denominator, 2 to the u plus some constant c, and I just replace u with sine x when I get done. So 2 to the sine x power all over ln2 plus some constant c. Here's a few of the homework problems that we'll do. We'll probably do most of the derivatives and integrals, and we're going to have to do one that you do using what's called the natural log method, which is interesting, and I'm going to go ahead and go through it here for a moment. So what happens if you have an x as both the base and the exponent? Well, basically we punt. No, we're not going to punt. We're going to say, okay, let's take the natural log of both sides. So instead of y, we say natural log of y is equal to the natural log of x to the 2 over x. This is just a rewrite. We haven't touched a derivative yet. We continue with the rewrite by using that one thing, the power thing that says natural log of x to the n is equal to n times natural log of x. So we're going to use that to rewrite this guy here. So when we finally do take derivative, it's going to look like a product rule instead of something funky like this. So all this is a product rule, so we take care of business. We've talked about before that the derivative of ln x is 1 over x, or the derivative of something more interesting is y prime over y in this particular case. So we go ahead and take the derivative, use product rule, we clean things up a little bit, and then this is the interesting step here. So if this is y prime over y and we just want y prime, we have to multiply both sides by y. And now, since this y here can be stated in terms of x, if we go back up top, we take whatever the original function is and we plug it back in. So this is y prime is equal to this whole bit, and they did try to clean this up in the book a little bit, and what they did was they just said, if I'm dividing like bases, this is basically x to the 2 over x and divided by x squared because this is in the denominator. If I divide like bases, I subtract the exponents. So this is x, this base, to the 2 over x minus 2, the two exponents subtracting each other, and then they just left the 1 minus ln x here. And one of those is plenty for anybody. So that's good for today. I'll show you a couple of the integrals. This one's kind of interesting. They actually did a problem here in number 64 where they just had numbers. So this is just the integral of a constant. Well, I can do that with geometry. And that's good for today. Thanks.